Well, no. Okay. Dear colleagues, it is very pleasant for me to present the results of our investigation. I would like to present the joint report that included two reports. Why two reports together? Because the ideology base of two reports is the same. It is a method coherent correlated states. It's better because in this case it's not necessary repeat once more the theoretical foundation of such methods. Okay, so it will be two parts. First part is related to the first title and another part to another one. So one introduction. The problem of optimization of nuclear reaction is the most important, of course, and in the case of low energy particles, it is well known the probability of such reactors is very low. Alternative methods for realization of nuclear fusion is the use of accelerated particles. In the report, the method of various sanction optimization of both processes, first and another one, at using of channeling, orientation motion, and also some action of magnetic field are discussed in detail. Let's very briefly report well-known results of nuclear physics. The problem of started nuclear fission at low energy is well known. In the usual case, we have the low energy particles because of very low transparency, coefficient transparency of potential barrier, so the probability is very low. On this figure you can see on the lower part the probability, coefficient probability is 10 minus power 7,000. It is approximately 0. Nuclear fusion at low energy presents, for example, screening. Screening, of course, decreases the weight of the barrier, but result is also not very optimistic because on the lower part you can see that using the screening in the interaction of nickel plus proton, energy of such screening equivalent energy is 250 eV. In this case, the coefficient transparency also is very low, 10 power minus 600. So, alternative method accelerated. Accelerated method also is very well not, but usually efficiency in such method is very low. But for example, if you can use the particles so much proton, for example, with energy 25 keV, so in this case the coefficient of probability is large. It is 10 power minus 8. But if you using the particles of very low energy, approximately energy 500 eV. It is, of course, the room temperature, but is not very high energy. The probability in this case will be also very small, 10 power minus 45. It is a standard point of interest of you. But I would like to introduce, and not introduce, but take in attention very interesting experiments by Steve Katinsky, our chairman, so one that he published several years ago. On this figure, you can see two main experiments from patent. First one, left. It is an experiment of the following. It is proton gun, generated protons, accelerated proton to energy about several hundreds electron volts, EV, only LV. And also, such beam interact with foil made of lithium. Another experiment, it is a low temperature hydrogen plasma, glow discharge, and also some voltage between source of proton and the target, and also approximately the same energy, about several hundreds electron volts. And what is interesting result? First one, system or direct accelerated particle interaction with solid targets. You can see lower graphs that in this case we have very narrow and intensive peak of such reaction at energy about 500 electron volts. Very, very strange. So increasing of energy lead to very essential decreasing of probability of interaction. And also left figure in the lower part, it is a result of such experiment of interaction of proton in plasma during the process of glow discharge with ions of lithium. You can see in this case, we have observed very intensive peak of alpha particles with energy about 8.4 MeV. It is well known, so 8.9 MeV. It is well known peaks, but there is absolutely is absent another peaks because these peaks it's related to the interaction of Li-7 plus proton, but is absent the result of alpha generation as a result of interaction Li-6 per proton. Because in this case, there is two peaks with energy about 2 MeV. Is absent totally. Why? Because it's natural lithium. Let's consider its problem in detail. There are two main questions for understanding this process. First one, why the maximum of lithium plus pair reaction at low energy is 500 electron volt? Very strange. Another one, why is alpha spectrum of lithium pair reaction? There are no alpha particles with energy 1.7 and 2.3 MeV, the result of interaction with lithium-6. According to our analysis, these processes are fully justified in the self-similar formation of coherent correlated states. Very briefly information, because I many times reported such results, such theory on such conference. Coherent correlated states. Well known in quantum mechanics and nuclear physics, traditional uncertainty relation of Heisenberg, well known, yes. It traditionally was created in 1928, and it is a description, it is a product of two variables, is limited by a constant, Planck constant, or commutator. This relation, for example, delta P more Z H divided by 2, it is possible use for estimation of barrier transparency. If you have usual gamma expression, unfortunately don't work. No. It is possible to introduce the so-named quantum mechanical skin layer in blue, using for example, such structure of potential barrier. In final expression, the same formal expression for gamma expression is a lower line. So it is an exponent power minus relation of size of barrier to the size of such skin layer. At very low energy, its relation is very large, and because it is minus power, it is probability is very low. Not interesting, it's well-known results. Okay, but in 1930, Schrödinger and Robertson independently generated the Heisenberg relation, introduces the idea of quantum mechanical uncertainty of different dynamical variables, that is a special coherent correlated state. In this case, we have modified coefficient of correlation, next in red line for formulas. What is the difference? In this formula, there is a value 1 minus r power 2. R, it is the coefficient of correlation. Coefficient of correlation is a parameter that describes the mutual coherency of different agent waves, the particles that are in the state of coherent superposition. What is important this result? Because in this case, it is possible in the case where the state is very close to totally coherency, parameter R is very close to units. In this case, of course, right part of this formula increases in limited. In fact, it's possible to introduce the renormed Planck constant, or effective Planck constant. In the case of coherent correlated states, such Planck constant increases unlimitedly. It is very important because the Planck constant, in fact, is a border between quantum mechanical and classical description of our world. So if Planck constant increases, so we can introduce quantum mechanical description on our macroscopic world. And also, if we had analyzed the same problem of transparency and introduce new formula for coherent correlated states, you can see a lower line. In this case, the coefficient of transparency for correlated states is equal coefficient in uncorrelated state power square root 1 minus R2. If R is close to 1 unit, so transparency of any potential barrier will be close to 100% at any low energy. What is the reason of such phenomenon? It's related to the foundation of quantum mechanics, and it takes place only in special superposition state, because superposition state we have such mixed of different agent state, and non-correlated states, this wave function on different states are not cophasing. It's absolutely independent. But in coherent state, we have the very intensive interference, and this interference lead to periodical formation giant fluctuation of pulse and kinetic energy. And of course, it leads to increasing of coefficient of transparency and other effects. Most important model for analysis for such process is related to the analysis of non-stationary harmonic oscillators. It is very simple description, not important now, but it is possible to calculate if we have such objects. So if we have, for example, potential barrier, potential hole, the structure is close to the harmonic oscillator, non-stationary. In this case, it is possible at such modulation of the size of dip of the potential hole or potential barrier, it is possible to create some coherent correlated states. Very small estimation. Next, for example, if we have the modified relation of Heisenberg-Schrödinger, and it is easy to calculate the fluctuation of energy. It is delta P power 2 divided by 2 massa. In this case, we have the new formula. Let's simple estimation. In the case of non-correlated state, in blue, the fluctuation of energy for typical distance of size of potential hole about 1 angstrom. So fluctuation is 0.05 electron volt, typical temperature energy. But in the case if we have correlated states with coefficient correlation 0.99999, so fluctuation of energy more than 25 keV. Very interesting. Of course, in such case, it's possible to optimize any nuclear reaction. Okay, some more information about coherent states. There is a result of analysis. We have conducted different analysis. The analysis where the frequency, equivalent frequency of harmonic oscillation modulated in periodical law, 1 plus G cosinus omega t, omega light t. If it is maybe or increasing of size or the modulation of dip of potential well. In this case, you can see the very sharp increase of coefficient of correlation, and coefficient correlation is several period of oscillation is very close to units. Difference is 0 point and several nines after comma. It is we have analysis different case. Most important is the modulation of parameters on the resonance frequency. If the frequency of modulation is equal to the initial frequency or equal to times, so now parametric modulation. It will be very important for next analysis. So we have also investigated all spectrum of frequency modulation. It is shown from analysis there is only 2 peaks. Peaks where the parameters of potential hole modulated with resonance frequency omega, and most interesting with 2 omega peaks, 2 peaks. Okay, let's now analyze the experiment that Steve Kretinsky conducted. Let's consider motion of accelerated proton with not high energy along the potential in the crystal, for example, lower part. In this case, we have the periodical changing of it is non-uniform potential energy of proton and such motion. Yes, it is easy to introduce. For example, unfortunately, don't work in my system. It is possible to introduce such a system. Oh, terrible! I cannot show. No. Oh, sorry. Just a moment. Yes, right. Oh, yes. Let's consider systems such situation. We can approximate the structure of potential barriers during the trajectory as a system of Gaussian function. Gaussian function, it is a periodical system. It is a radius of electron screening. So from the other hand, any potential barrier for parabolic approximation may be noted in the traditional view because mass square x transversal coordinate and frequency of non-uniform frequency there is. Okay. In the coordinate system moving with the particles, the velocity where the potential and corresponding to non-stationary harmonic oscillator. So we can discuss such or calculate such system based on traditional method of analysis of non-stationary harmonic oscillator based on this formula. So frequency, equivalent frequency oscillator will be changing periodically with such value. Okay. On this figure, you can see the result on left part. it is received as a result dependence of the coefficient of, it's not correlation, it's coefficient of efficiency of correlation. It's efficient is a unit divided by square root 1 minus r square, because coefficient correlation is units that is as follows structure, 0 point in several nines. But coefficient correlation may be changed from 1 up to unlimited value. So it is direct following from analysis that in the spectrum of such value, there is very, very intensive peak on the double frequency, because it is a direct result that was analysis in model system. And if particles moving with such velocity, we have the very intensive increase in coefficient correlation. It is a number of period along the trajectory of motion. So if we can calculate what is the optimal energy will be, it is a square power, this optimal velocity, m divided by 2, it will be the same interval from 400 up to 600 electron volts. So if a particle is moving along the periodical crystal with such velocity, the very effective increasing coefficient correlation, increasing fluctuation of energy take place. Fluctuation energy may be, there is some results here, it may be more than 40, 50 and more keV. It is a very good energy for realization of nuclear interaction between moving particles with atoms of lithium that create of atomic crystal. It is the same description. It is also some calculation. In this case, we very intensive increase in both coefficient of transparency and cross-section of interaction. It cross-section up to value 10 power minus 30 centimeter power 2. And it is a method of calculation. It's lead to very intensive increasing of rate of reaction. For example, it is easy to calculate that number of reaction increases more 10,000 reactor per second. It is very close to the result of experiment of Katinsky. And also, the same effect may be used for analysis interaction particle not with crystal, but with usual molecules lithium. It's a part of the vapor in the volume. It is also easy to calculate. In case so, motion of particle, it is equivalent formation of non-stationary harmonic oscillator. It is a calculation of coefficient of correlation, analysis of optimal velocity, also optimal velocity 2 times more than average velocity, and also increasing of coefficient of correlation along motion particle through such molecule. Also, maximal coefficient efficiency more than 1,000, and result it leads to the possibility of fluctuation of energy with an interaction of proton that moving in such optimal energy. It is about the same about 500 eV, increases several tens keV. So it is a result why this process takes place, why the great velocity, why the great probability of reaction. Another question is related to the absence of reaction with Li-T6. It's related to the specific of interaction of particles, optimization of interaction with using of virtual energy, because fluctuation of energy is not realistic energy, it is virtual energy. It is very simple analysis. For realization of any reaction by the fluctuation, it's necessary some steps. First one, it is passing particle to barrier, transition through barrier, formation of compound nuclei, and generation of energy. If such energy is generated as fluctuation energy, as fluctuation parameters, it's necessary that all this cycle might be finished during the time that equal to the fluctuation of time. So let's consider, for example, 2 possible reactions. One reaction, it is a reaction Li plus proton. Such reaction, duration such reaction is very small, 10 minus 20 seconds, and generation 2 alpha particles with such energy. Okay, if, for example, if we need for energy, for example, for such reaction, 10 from 10 to 100 keV, so, and coefficient correlation in such fluctuation in the case of correlated cell can exist such time about 10 minus power 18 seconds. It's much more than reactive time of reaction. So during existence of fluctuation of energy, it is possible to conduct all process of passing particle, transition particle, formation of compound nuclei, and generation and return energy. In the case of another reaction Bt6 plus proton, what is the difference? Different sections duration is very long because the difference is 7 order. Of course, such time is much more than the same duration of reaction. So such reaction is absolutely impossible. Because virtual is a result of virtual energy, it is not possible simulated reaction with long time of life or long time of decay of compound nuclei. By this reason, it is very strong suppression gamma radiation. Because if we have excited nuclei after absorption particle, any nuclear decay, some most accelerated decay, type of E1, electric dipolar transition, duration such reaction in any case more than 1 femtosecond. No in nature reaction with less than 1 femtosecond. But according to our calculation, duration reaction need to be small, very small, is absent. So gamma radiation is totally suppression, and also totally suppression creation of radioactive ash, because any radioactive ash, radioactive dirty nuclei, it is isotope with very long time of existence. So return energy will be in a long time, but according to virtual theory, energy need return immediately, because in other case, such channel of reaction isn't possible. And also, it is the first report, Maya. And the next one is the report is LENR in weakly ionized gas under the action of optimal pulsed magnetic field. It is well known from the experimental base of nuclear physics that they very often observed the process of generated neutron at, for example, electric arc discharge, for lighting, for different processes. Very interesting. There is some works, many is very works such similar, and it is our analysis has shown that such processes also it very good maybe explained by using or application coherent correlated state. Let's consider a very simple system. System with gas, for example, free molecules with mass m and charge q, and also current, pulsed current, for example. Motion, electric current lead to generation of azimuthal magnetic field. Motion of any ion in magnetic field is totally similar to the harmonic oscillators with Pearsonov-Landau quantization, well known. So any charged particle is magnetic field is the oscillator. If we have a pulsed electric current, it leads to formation pulsed magnetic field. So to formation for short time non-stationary harmonic oscillator. Let's consider such process. If, for example, if magnetic field changes in such low, it is initial very small frequency magnetic field, and also increasing, for example, in the view of the similar Gaussian function. It is easy to calculate the process of formation correlated state and generation of giant energy fluctuation system. On this case, you can see formation of such correlation function, Harris. Correlation function, it is function, it is dependent from the time. Very interesting, dependent coefficient of correlation, averaging of current, as function from product of magnitude of magnetic field and the duration of magnetic field. It is phase space, for example. Very interesting, such process takes place only at such optimal combination of magnetic field, amplitude, and duration. In any case, it is the same situation. For example, there is some additional expression. We have analyzed formation of correlated states for different amplitude magnetic field, different 5, 10, 5 relative magnitude, 5, 10, 15, and so on. In all these cases, the product of magnitude magnetic field or equivalent maximal frequency oscillation, Landau frequency, by duration of oscillation, absolutely the same. It's led to very interesting result. So parameter product of such value, maximal frequency landau by duration, is constant. Because this value is related to the well-known parameter, the duration, charge, up to the magnetic field, mass particles, and the light velocity. So we have the modified Lawson, in fact, modified Lawson equation, Lawson condition. So such process may be possible only in this case if the product duration of pulse to the amplitude of magnetic field is equal to such value. It is ratio mass because calculation was made for proton. It is a mass of investigated particle to mass of proton. Or the same, it is a product of duration, amplitude of magnetic current, electric current, and distance from current to the point of observation. For example, if we have tau, for example, 10 power minus 10 minus 7 second, and in the case of proton, the optimal amplitude of magnetic field is 600 Ørsted. And tau is 10 power minus 8, we need amplitude of 6 kilo electron volts. So, if the condition will be destroyed, if not satisfied, process not be possible. If we have fluctuation magnetic field or more strong or different of such value, effect will be impossible. It is very interesting condition, and this result explains the difficulty of obtaining or guaranteed LENR and poor repeatability with random choice of parameters. Very interesting. We need very precision using parameter of our system. This result was published last year in the journal, Journal of Experimental Theoretical Physics. The said more effective processes include generation of neutron and many reactors take place during, for example, light in the atmosphere, because in many experiments such products is observed. Yes, I'm finished. So very interesting. So that process of application of coherent state is possible not only condensed matter, not only crystal, liquid, and also to gas and low energy plasma. In my opinion, the term of CMNS may be interpret not condensed matter system, but controlled matter nuclear system, because the process not only in condensed matter, but also in gas, plasma, so on. And also some description by I have discussed this. And also for information, there is a very large list of articles on the application of coherent correlated state to different systems. It is about several tens publications. It is only made one. Thank you for attention, and excuse me for very long speech.
Very nice, interesting talk. I'm talking about, first of all, for the first talk. My question is, okay, the proton is coming in the lithium target. Does it suppose the proton to deform the existing potential? You see now, because I agree that the incoming proton may not deform the existing potential, but how about the treatment in this way, in this model? Did you understand my question?
This problem is described in general. This may be proton, it may be different ions. This main idea is the following. We have the charged particles, we have non-stationary potential. In non-stationary potential, the process of formation of coherent superposition state takes place. In coherent superposition, because the cophasing of different agent state, formation very giant fluctuation of energy. In any case, it's not dependent what is the nature of particle. It may be proton, it may be electron, it may be heavy ion, so on. Generally, in any case, it's necessary to calculate the detail of this process. Using screening or without screening, maybe some different, but in any case, without formation correlated state, typical energy of potential is very close to 0.05, for example, eV. For formation of realistic coherent states, fluctuation of energy may be several tens or more keV. It is more important. And also another one. It is very important for analysis of all experimental length, not only high coefficient of transparency of barrier, but also total absence of radioactive ash, radioactive total isotope. But such effect is described and can understand what is the reason why channels that Okay.
Thank you, Vladimir. Excellent presentation again. I have a question about the stimulation of the sample, the matrix you are describing in your graphical representation. If we take the sample where you shoot beams at the sample using the proton accelerator, have you evaluated not the energy of the beam that is shot at the sample, but the rate at which the protons are going? Because you can tune the rate to...
You asked me what is the difference between motion of single particle as beam?
No, it's not that. It's the rate at which we shoot proton to your samples.
Yes.
You might be able to stimulate another coherent parameters by changing the rate at which the protons are shot at the sample. So you can maybe eventually... Have you thought about that?
Yes, I have no time. Unfortunately, it is related to the spectral theory of Fourier transformation. I show some results. Most optimal case
We have
will
to
be
stop
if
the
the
session.
frequency of equivalent modulation equal 2 times more than average frequency. So particles need move with optimal velocity or moving in periodical structure with optimal energy. It is at such angle give you the maximal density of probability of excitation. It is very, very narrow. It is very long because the list of
1 minute.
particles is
Okay.
very large. We discussed it many times. Sorry.
Okay.